Question 11a. Make M the subject of the relation H equal to MT over D bracket open M plus P bracket close. Solution. This is the relation. Let us write H over 1 so that you can cross multiply to clear the fractions. So you have it in this form. So H times D bracket open M plus P bracket close and MT times 1, you have it in this form. You have to open the bracket in the left hand side and you have HDM plus HDP equal to MT. The terms that contain M, take them to one side. That is collection of like terms. So let's have HDP here. MT is already here. If you transfer plus HDM, it becomes minus HDM. In the right hand side, you factor out M. So you have HDP equal to M bracket open T minus HD bracket close. To get M, divide both sides by the coefficient of M. So M is equal to DHP. Now, I'm trying to follow the order of the letters. So you have DHP over T minus DH. That is M as the subject of the relation. 11b. In the diagram, WY and WZ are straight lines. O is the center of circle WSM and angle SWM is 48 degrees. Calculate the value of angle WYZ. Alright, so we have it that WZ is a straight line and O is the center, and WZ passes through the center of the circle. That means this angle here must be 90 degrees. So we can join these 2 points together. So if this angle is 90 degrees, you can get this angle by adding the 3 angles in triangle MSW and equate it to 180. After that, you can consider SMYZ as a quadrilateral, and the sum of the opposite interior angle of a cyclic quadrilateral is 180. So if we can get this angle, it helps us, or it can help us to get this angle. Since you can get this angle from the other triangle, these 2 angles are in a straight line. To enable you get this angle, and you add it to this angle, equate to 180 to get this angle. Let us see all of that. The solution continues. I've already explained the adjustments in the diagram. First, we have to get this angle. If you add all the angles in the triangle is equal to 180, we are interested in WMS. That is this angle. The rest 2 angles are 48 and 90 respectively. So WMS is equal to, you transfer these 2 angles to the right hand side and you have 180 degrees minus 90 degrees minus 48 degrees and is equal to 42 degrees. Next is to get this angle. So we take the 2 angles on a straight line. That is angle SMZ plus angle WMS equal equal to 180. And what we need now is SMZ. SMZ. This is the angle that we need. This one is 42. If you transfer it to the right hand side, you have angle SMZ equal to 180 degrees minus 42 degrees, and that is 138 degrees. In the quadrilateral SYMZ, angle WYZ plus angle SMZ equal to 180. That is this angle and this angle. The reason is that opposite angles of a cyclic quadrilateral, we are interested in this angle, so you transfer this, which is 138, to the right hand side, and you have angle WYZ equal to 180 degrees minus 138 degrees, and that is 42 degrees. Let us look at question 11C. 11C, an operation. This operation is multiplication in modular arithmetic, is defined on the set S equal to curly brackets 1, 3, 5, 6 as the element by m times n equal to m plus n plus 2 modulo 7, where m, n are members of S. Figure 1. Draw a table for the operation. Figure 2. Using the table, find the truth set of part 1. 3 times n equal to 3. Part 2, n times n equal to 3. Solution. Figure 1. You have the table for the operation m times n equal to m plus n plus 2 modulo 7. To form that table, you write the set, the element, in row and column wise. Let us take this column. This is the column view now for m and the row view for n. Now, in modulo 7, you have 6 elements from 0 to 6. As you will carry out the operation, any element above 6, you always divide it by 7 and you record the remainder. But if it is between 0 and 6, you always record it. So let's take this one against this one. That is when m is 1, n is 1. If you put 1 here, you put 1 in place of m, you put 1 here. This 1 plus 1 is 2. 2 plus 2 is 4. 4 is an element in modulo 7, so you record it. Now you take the same one against 3. That is when m is 1, n is 3. When you add, you have 4. 4 plus 2 is 6. 6 is an element in modulo 7. You record it. You take 1 against 5. That is 1 times 5 is 6. 6 plus 1 times 5 is 6. 6 plus 2 is 8. 8 is not an element in modulo 7, so you cannot record 8 here. What you do is that you divide 8 by 7 and you have 1 remainder 1. What you record is the remainder, hence here is 1. You take the same one against 6 and you have 1 plus 6 is 7. 7 plus 2 is 9. Divide 9 by 2. You have 1 remainder 2. You record the remainder. You take 3 against all the n elements and you have the second row, you take 5 and you take 6. Now let's try 6. If you try 6, when m is 6 and n is 1, you have 6 plus 1, that is 8. That is 7. 7 plus 2 is 9. Divide 9 by 7, you have 1 remainder 2. You record 2. You take 6 against 3. 6 plus 3 is 9. 9 plus this 2 now. 9 plus this 2, you have, okay, 9 plus 2, you have 11. If you divide 11 by 7, you have 1 remainder 4. You record the remainder 4. You take 6 against 5. 6, when m is 6, n is 5. So you come here. 6 plus 5 is 11. 11 plus 2 is 13. Divide by 7, you have 1 remainder 6. So you record remainder 6. See that? You take 6 against 6. When m is 6, n is 6. That is 6 plus 6 is 12. 12 plus 2 is 14. Divide 14 by 7. You have 2 remainder 0. You record the remainder 0. So that is the table for the operation. Remember, we got 2, part 1. 3 times n equal to 3. What that means is that m is equal to 3 and n is equal to n. Now, which value of n will you multiply by m3 to get remainder of 3? What you do is that this is the m row. So in the m row, you locate 3 and you trace 3 to where you have remainder of 3. When you trace it up, you have 5. So n is equal to 5. Roman figure 2 or part 2 of Roman figure 2, n times n equal to 3. What that means is that two the same value, that is, okay, let's start with 1 1. When m is 1, n is 1, the remainder is 4. You cannot take n as 4. So you try 3 against 3. The remainder is 1. You cannot take m and n as 3 because you must have remainder of 3. You take 5 and 5. Remainder is 5, not 3. You take 6 and 6. Remainder is 0, not 3. So considering this table, n has no truth set. That is the answer, because no two the same number give remainder of 3. So this is the end of question 11. Let us proceed to question 12.